Hello there, algebras, and welcome to Chapter 1, Lesson 6, Day 2. So today, when we're talking about inequalities, we're going to talk about just graphing or interpreting the number lines, the solution sets of compound inequalities. So compound inequalities are when we deal with and or situations. So when we define and when it's used in math sentences, we mean both situations have to be true. And when we define or, one of the two has to be true. And I'll write out the has to be true. And it's going to end up being interpreted in specific ways as far as how we write those inequalities. So I'm going to start with and. Both situations have to be true, okay? Graph x is less than 3 on the number line. And then graph x is greater than -1 on the same number line. So let me show you how that's going to look. X is less than 3. Well, that's an open circle over 3. Here's 3. And less than 3, less than, we go this way, right? Here, I'll stop right there. I'll put my arrow. Now, graph x is greater than -1. Well, look, that's an open circle over -1, and greater than -1 heads this way. And what do we notice? There's a gap, or excuse me, there's an overlap between these two. This is an and situation. So this and situation means that all of the things between -1 and 3 will make this happen because both situations need to be true. We need to be smaller than 3 and we need to be greater than -1. So here I'm asking for shared integer solutions. Integers are those whole number or the opposites of your whole number solutions only. So the only whole number solutions that we have here are 0, 1, and 2. Obviously, there's an infinite number of numbers between 0 and 1, right? So 1/2 and 1/3 and everything between them, right? So we know that there's an infinite number of numbers that could be a part of this solution set, but the shared integer solutions is only 3, 0, 1, and 2. Okay? Now, and inequalities, because both situations have to be true, they have that between line. So that line that's between your two values, that we're dealing with, right? So I like to call these betweeny inequalities. So these are always written the same way because left to right is less to greater. These are always written the same way, which is the x, and the x is the line, right? So the x is between two values, and it's always between less than signs because we read left to right, and smallest is to the left. This is the smaller numbers. Greatest is to the right. So these are the greater numbers. So smallest to largest. -1 was the smallest. X is all this in between. So less than x, less than 3 is the greatest. We call that a betweeny inequality. So I call that a betweeny inequality. So instead of writing out x is less than 3 and x is greater than -1, you can write it this way, and you don't even have to write out the word and. We just assume that because x is between these two things, both things have to be true. Okay, so given a betweeny inequality, let's graph. Let's graph the solution set for this, okay? So -4 is less than or equal to x, which is less than 4. -4 is less than or equal to x, less than 4. Okay. X is between. So the line that's between these two values will be the values x is allowed to be. So these two are the numbers in question. So let's put circles over -4 and +4. Now, do either of these circles get filled in? Yes. Which one? -4. Why? Because it's next to the less than or equal to. So this number in question gets filled in. Will +4 circle get filled in? No, it does not have an equal to piece. X cannot be 4. Can X be -4? Yes. Okay. Now you connect because X is everything in between. X is between your two less than signs. X is everything in between here. This is an and inequality. Both situations are true at the same time. So this is both situations are true. Okay, both situations are true going on here. Compound inequalities. Compound inequalities. Okay. Let's graph X is less than -4. Okay, that's fine. And on the number line, and we'll graph X is greater than 0. So X is less than -4, less than smaller, that goes to left over here. Now let's graph X is greater than 0. Okay, so still an open circle over 0. Greater the X is greater than, that goes this direction over here. Oh, interesting. Did we have any overlap happen? No. Are there any shared solutions? No, there's no overlap. There's no overlap. There's nothing they can both be at the same time. So if there's nothing that these can both be at the same time, only one of them can be true at a time. There are no shared solutions here. Okay, so I cannot write it in this form because there are no shared solutions. Because there are no shared solutions, X has to be either smaller than -4 or it has to be bigger than 0. It can never be both at the same time. So X can never be both smaller than -4 and greater than 0 at the same time. Whenever we have explain, we need to use a sentence to explain. So sentence full of nouns and verbs and a period at the end, right? Can never be both at the same time. Both is an and inequality. One or the other is an or inequality. And thankfully, our English language actually backs this up. It backs up our mathematical language about this. Okay? One at a time. How about we capitalize all of them? Okay, one at a time. Great place to stop and take it in. Look at it all, right? Okay. So we're going to do some translating of situations into compound inequalities. So we're going to write some compound inequalities based on these situations that we're going to read about. And then here we're going to be given some compound inequalities and we're going to put them on graphs, or we're going to be given graphs and we're going to interpret our compound inequalities. Okay, here goes. Swimming pools must have a certain amount of chlorine content. Okay, the United States standards for safe levels of chlorine in swimming pools is at least, feels important, 1 part per million, and no greater than 3 parts per million. Write a compound inequality for the acceptable range of chlorine levels. So the smallest amount of chlorine, at least, right, is the smallest amount of chlorine I'm allowed to have. And I can't have greater than 3 parts per million for this chlorine. So I'm going to make C my variable. And it sounds like C, the amount of chlorine in the pool has to be between 1 and 3. Does that make sense? Can it be 1? Because it says it has to be at least 1. Yep. So we can include the equal to part. Can it be 3? Yes, but it can't be any bigger than 3. There you have it. Unsafe body temperatures are those lower than 96 degrees or higher than 104 degrees Fahrenheit. So, are there any unsafe body temperatures that are both smaller than 96 and bigger than 104 at the same time? No. Since that's the case, this is an or. And by the way, the word or is literally written in the problem, right? So it helps you make that call of are both things happening, or is only one thing going to happen here? And only one of these things can happen at a time. So temperature, I'll use T as temperature. It has to be T is less than or equal to 96 degrees Fahrenheit, or, and we literally write the word or, T has to be greater than or equal to 104 degrees Fahrenheit. Those are unsafe body temperatures. Although I'd argue that if you're spiking a fever at 101, 102, 103, you're probably not in great shape. Look at the difference between those, right? The and the or. Look at the difference between how they worded those things. Okay. You used anywhere from 1,200 to 2,000 text messages last month. Probably low for some of you people. Oh, this to this. Oh, that's a between inequality. So T for text, 1,200 is less than or equal to T, which is less than or equal to 2,000, right? The lowest you used to the highest you used. There's tons in between there, but somewhere in there is what you text last month. What, in one day last month? Knowing you people. This is so gross. Since 2011, the winners of the Nathan's Hot Dog Eating Contest have eaten 62 to 69 hot dogs to win. That is disgusting. Again, look at that. It's this smallest number to this largest number. They're telling you in the way they word the problem that this is and both have to be happening. It's between these two values. So that's a between inequality. 62 is less than or equal to H for hot dogs, right? Which is less than or equal to 69. So the winner of this hot dog eating contest has eaten between those amounts of hot dogs. Yikes. Please don't try doing that yourself. I beg of you. Well, these are nice. Solve and graph each inequality. Oh, how about there's nothing to solve? That's easy enough, right? Hey, cool. 4 is less than or equal to x, which is less than or equal to 8. So you get to make your own number line for this guy. So 4 and 8 are my values in question. So I want things to kind of circulate around 4 and 8. So what I'm going to do is I'm going to put enough hash marks as evenly spaced as I can, since I'm freehand, on my number line so that I have plenty of room between 4 and 8. So 4, 5, 6, 7, 8. So if I go by ones, I can fit with plenty of room. I get some above and some below. I really don't have to fill in this whole thing, but I did because I've got plenty of space on each side. 4 and 8 both get circles over them. Let me then just think about if I fill in any of those circles. So let's see, there's an equal to part next to the 4. So 4 is going to get filled in. There's an equal to part next to the 8. So 8 is going to get filled in. It's got the extra line, fill in the extra. And then X is literally between those two inequality symbols. So the line will be between those two values. Betweening again. not a between. If it says or, you're going to go opposite directions. Okay. So we need to have our numbers in question are -1 and 8, right? So we need to be able to fit values from -1 all the way up to and including 8. So I've got plenty of hash marks on here as evenly spaced as possible. So let's throw -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Some numbers above, some numbers below. And circle over -1, circle over 8. Okay, not filled in, not filled in. Easy enough. X is greater than 8. 8, what's greater than 8? 9, 10, 11, on to and including positive infinity. So there we go. X is less than -1. Okay. All the values smaller than -1, -2, -3, on to and including negative infinity. Notice with the or, we're going to go in opposite directions. The and the written between inequalities will come together between your two values because both things have to be true. So we've got shared solutions. The or, only one can be true at a time, so they're going opposite. They're going out. They're going different directions. So where I really want to show you that is number 5. X is less than or equal to 4 and X is greater than 1. So this was not written as a betweeny inequality. However, the word and tells me both have to be true at the same time. So I still need my values in question. And I'm just spacing out a little more because these are closer together than the other values have been. See, right? Open circle over 1, open circle over 4. Fill in that circle over 4 because we've got an equal to part. Do not fill in the circle over 1 because we do not have an equal to part there. And since both things need to be true, X has to be less than or equal to 4 and X has to be greater than 1. Since both have to be true, they have to be coming together. So come together. You can rewrite this as a betweeny inequality if you want because X is between 1 and 4. So 1 is less than X, which is less than or equal to 4. When writing a between inequality, these two things mean the same. When writing a between inequality, it's smallest number, less than X, less than largest number. It's always the same. Okay. I call it a less than sandwich. X is the middle of your less than sandwich. So here we go again. Number 7. If you have a number line completed, is there a line that's connecting your two circles, or are we going out? If we're connecting, it's an and, so you can write it as a betweeny inequality, right? You look for the smallest number, then a less than sandwich, then the largest number, the largest value, okay? Now, you decide if you put inequalities, you've put equals under your inequality signs, you're under your less than signs, based on whether your circle is filled in or not. Filled in? Yep, put an equal sign. Filled in? Yep, put an equal sign. There you go. If you're going out and away from your circles, so these are not coming together, these are going out, this is an or, and you write two completely separate inequalities because we're never going to have shared solutions. So this is saying that 0 is your number in question and all the values are smaller than 0. So this is X is less than 0, no equal to part because there's an open circle over 0, or, because that's one direction, the other direction is that X has to be greater than or equal to 2. And I say greater than or equal to 2 because 2 is filled in. There you go. All right, one more betweeny inequality that I'll write, one more or that I'll write, and then you start practicing. So here's a betweeny. Smallest number, less than sandwich, biggest number. -3 is less than X, which is less than or equal to 0. less than sandwich. X is in the middle of the less than sandwich. Down here. Okay. So this is two completely separate inequalities because it's going the different direction. So you're going to write two completely separate inequalities with just an or between them. X is either smaller than 0, so X is less than 0, or X is greater than 1. And you're done. Alrighty, guys. You got this. Go ahead, get to that practice. We'll see you on the other side. Have a wonderful rest of your day or week or whatever it may be.